Lesson 18, projectile motion at an angle. So here's where we combine everything we know up to this point and figure out some pretty serious problems. Projectile motion angles, like kicking a soccer ball, throwing a football, throwing any kind of ball, launching a missile, anything that once it is set in motion, the only thing that's acting on it is gravity. So that's the definition of a projectile motion, when only gravity is acting on it. And this time, instead of launching it horizontally, we're going to launch it at an angle. So here's a soccer ball, for example. Here it goes. And you'll notice the red vectors this time are horizontal. And once again, they're exactly the same size throughout. The horizontal velocity remains constant. So if you're standing far away from this and you're measuring the horizontal velocity, it is constant velocity. Therefore, only the formula V equals d over t is applicable to the horizontal component. Once again, the vertical component starts really big because now you've given it some initial vertical velocity, gets smaller and smaller, becomes 0 for an instant, and then gets bigger and bigger. And again, note that this vector here on the end and this vector here on the end are the same magnitude in opposite directions. So this vector here and this vector here, same magnitude, opposite directions, and so on. Okay, and other than that, you solve these problems the same way that you do horizontal. You've just got this one little piece of information. So let's go right to the problem. You kick a soccer ball at an angle of 40 degrees above the ground with a velocity of 20 meters per second. Determine how high it will go, how much time, how far, and what's the velocity when it hits the ground. So in other words, this sounds very similar to the previous question, but now we've got the added dimension in that it has an initial vertical velocity. So here's your little sketch. There we go. We're kicking a soccer ball. Now, don't put 40 degrees in here. Like right there, don't put 40 degrees because you need to make a separate triangle. This is clearly not, the shape that I've drawn is a parabola. It's not a triangle. So we're going to make a separate triangle. But we can label this. That's the vertical displacement. From here to here is the range, or the horizontal displacement. We know that the vertical velocity at this point is 0. So V equals 0. The vertical velocity, remember the horizontal velocity was always constant. So those are just some things we can put in if we want. Now let's take into account that 40 degrees. And again, we're going to do it separately. And where does the 20 meters go? Well, since the 20 meters is not attached to a horizontal or vertical component, then it is automatically the hypotenuse. So there's our 20. And that is a velocity. And lo and behold, as we love to do, we can separate it into x and y components. And the x component represents the horizontal velocity in this case, and the y component represents the initial vertical velocity. I'll say that again so it's really clear. So 20 meters per second is the overall velocity, but the x component represents the horizontal velocity, constant velocity, uniform motion, and the y component represents the initial vertical velocity. So we can use sine and cosine as we always do, and let's just kind of skip right to the answer. So the x component turns out to be 15.32. In other words, it's moving horizontally at 15.32 meters per second throughout the entire trip, throughout its entire journey. And the y component using the sine trigonometric ratio is 12.86. Okay, now that we've got those, we're going to proceed exactly as we did the last problem. We're going to write down what we have horizontally and write down what we have vertically. Can I move this? Yes, I can. I'm going to spend this entire lesson moving this thing. Oh. Okay, hopefully that gives us some space to do this question. Horizontal and vertical components. So horizontally, what do we have? We have the velocity. Do we have the time? No. Do we have the displacement? No. Vertically, this time we have the initial velocity, which is going to be positive 12.86 meters per second. We always, in the vertical components, have acceleration due to gravity. And just a reminder, it's always negative. Even though the ball is going up, it's still accelerating down because it's slowing down. So it's going in a positive direction, but slowing down. Therefore, it's negative acceleration. Acceleration due to gravity is always negative. What else do we have? We don't have the displacement. And we don't have the time. Now, do we have the final velocity? That is one of the interesting parts of this question is yes, we do, but there are two different answers. At this point, right here, then the vertical velocity is negative 12.86. But at this point right here, we said the vertical velocity is 0. So vertical velocity, well, sorry, final velocity equals 0 or negative 12.86 meters per second. And the one you use is going to depend on what the question is asking. All right, so now let's go to the question. And the first question says, how high will it go? Well, that's obviously a vertical component. So we're going to go to our vertical, and the only question you have to ask yourself is, are we going to use 0 or negative 12.86? And we just want to determine how high it will go, and it reaches its maximum height when the velocity is right there, 0. So for A, we're going to use 0. A. And the other variables that we have VF, we have we're trying to find the displacement. We have VF, A, and VI, so we're going to use and this time we're going to solve it for D. So the displacement in this case turns out to be VF squared minus VI squared all over 2A. And then we can plug those numbers in. It's going to be 0. Well, let's actually do this one. So it's going to be 0 squared minus VI 12.86 squared divided by 2 times negative 9.81. You stick all that into your calculator, and you will get an answer of 8.4, positive 8.4 meters. Which seems like a reasonable answer for kicking a soccer ball. Okay, let's go. After I move this once more, let's go to B. B says, how much time does it spend in the air? Okay, so here's what we have. Can we use the horizontal component? That's always the first one you look at, because the horizontal component only uses one formula, and it's the easiest formula we have in physics. We can't do it because we don't have the displacement. So we have to go to the vertical components. We're looking for the time. Now, here is where you're going to have to, again, look at this VF and ask yourself, we want the entire time that it's in the air, which means that the initial velocity is going to be 12.86, and the final velocity is going to be negative 12.86. So here's where we choose the negative value. Squeeze over here. B. Right, we're trying to find time. Which formula has time, final velocity, acceleration, and initial velocity? And that would be solve for time. So it should be VF. Plug in the numbers. the F is negative 12.6 minus positive 12.6 divided by negative 9.81. And note that the negatives are all going to work out because you're going to end up adding those two on the top. That's going to be a negative answer. Divided by another negative answer, you give you a positive time, which shows you're on the right track. If you end up with a negative time, then that clearly cannot work. So you plug those numbers in, and you're going to end up with 2.62 seconds. All right, and once again, as soon as you calculate that time, you can go back up to here, and you can, oopsie, you can plug it in there. So now we can calculate the range. Are they asking for the range? Indeed they are. How far away from you will it hit the ground, aka range? So that is the range. That's a nice easy one now that we've got this 2.6. Simply the horizontal velocity times the time. It's going to give you an answer of 40. And then the last question. Once again, we can do the last question. We can fit it in here. The last question is same as the previous lesson. What is the ball's velocity when it hits the ground? Now that one, that's an interesting one because of course we have the initial velocity and it has a vertical and a horizontal component already. So basically what we can say is, for that question, for D, we know that coming down it's going to be the exact opposite. Now you cannot put negatives on hypotenuse. You can only put negatives on horizontal and vertical components. So the hypotenuse will never have a sign, positive or negative. It's really neither. So all we need to do for this one actually is, well, actually you don't even need to do that. So we know that it's going to hit at exactly the same angle. And so the answer for this question is going to be 20 meters per second at 40 degrees up from the horizontal, just the way that I depicted it there. I'm going to say 20 meters per second, comma, 40 degrees up from the horizontal. Okay, now you could also say that that's 50 degrees below the horizontal. That would also be an acceptable answer. But just because the ball flies like this, it's kind of appropriate sometimes. Well, I told you not to do this. Never put a right angle triangle here. It just seems more intuitive to put the 40 degrees right there. All right, that ends that lesson. Now, there's going to be a part 2 to this lesson where we deal with another type of specific projectile motion question, which is where you throw something off a cliff, basically straight up, and then it hits the ground. And so we'll do that in the second part of this lesson.